Hello students, welcome to the Edubbey Global Solution. Again, in our mathematics class, we're going to be looking at a subtopic under differentiation, which is gradient of a curve. In this class, we have various examples that we will have to solve related to this topic, which is what? Gradient of a curve. And after which we are going to be looking at tangent of a point where we need to draw the gradient from the curved line of a graph. Our interactive content here will serve as a guide for this class. Okay, now for the first example we have here, we have gradient of the curve at a point. So if you are to get the gradient of the curve at a point, differentiating the equation of the curve, give the general equation for the gradient of any point on that curve. Now for that, we have an example here. We say that we should differentiate f of s equals to 1 over 2 x raised to power 2 minus 2x plus 4 with respect to x. Then after we should calculate the gradient when x equals what? When x equals 4. Okay, so what we need to do here is first and foremost, based on what the question implies, we are to differentiate just first derivative. Now after we have gotten the first derivative, then we put in the function of f of s to be equal to 4, then we'll be able to get what our gradient curve looks like. Okay, so f of x equals to 1 over 2 x raised to power 2 minus 2x plus 4. Now, under differentiation, the differentiation rules that we have is what? Ax n raised to power 1, right? That's the formula for differentiation. An x n raised to power 1. So that's what we are going to be applying. For this one now, 1 over 2 is the a, 2 is what? N. For this one now, the power of s is raised to the power of 1. And I've told us earlier under differentiation that any power that is raised to constant will give us what? 0. Differentiation of a constant will give 0. We've made mention of that in our differentiation rule, the previous classes under differentiation. Okay, so we are going to have 1 over 2, okay, multiplied by n, which is 2, x raised to power 2 minus 1 minus 2 multiplied by 1, and n here is 1, x 1 minus 1 plus 0. Differentiation of the constant will give 0. So this we cancel this, 2 we cancel 2. We have 2 minus 1 will give us what? 1. So we have x minus x raised to power 1 minus 1, that is 0, right? X raised to power 0, 9, this is we give 1. So 2 times 1 will give 2. So the new function after differentiating the very first time is now x minus 2. So what we just need to do here now, we are going to be replacing the function of our gradient when x equals 4. So we have f s equals 4 now. So instead of x, now wherever we see x, we are replacing it with what? With 4. So we have 4 minus 2, that is what? 2. So the gradient of this given illustration is what? Is 2. Now let's look at the next example that we have here. Okay, we have to calculate, when calculating the value of x when the gradient is what? Is being given. Now this is useful to calculate the unknown x coordinate point when the gradient is being given. Now from here we have a question here, we have an example. The function f of s equals to x raised to power 3 minus x raised to power 2 minus 5 has the gradient of 8 at a point P on the curve. Calculate the possible coordinate of point P. Now, for this first thing we need to do here is what? We need to differentiate the very first time, the first principle. After we are done differentiating the very first time, then we place the gradient value into it based on the fact that we are looking for points here. You understand? Not that we want to know the gradient, but we are looking for point, that is coordinate point on the graph. Then after that, we calculate the possible coordinate point of P. So let's start with the first one. Let's differentiate this. By the time you differentiate the very first time, you are differentiating f of x into which is equal to what? X raised to power 3 minus x raised to power 2 minus 5. Differentiation of the constant will give us 0. So let's differentiate this first time. Yeah. X, that is 3, right? Multiplied by x raised to power 3 minus 1 minus 2 multiplied by x raised to power 2 minus 1 minus 0, because this is constant. Now 3 minus 1 is what? So this one will give us 3x raised to power 2 minus what? 2 minus 1, that is 1 minus 2x. So that is the differentiation after we might have gotten the first differentiation for the question. So we equate this now to the gradient of p, which is p already. We already have the gradient function here to be p. Now, by the time let's try to solve this and let's see. You know that this look like what? This will look like a quadratic equation. After we are done, we'll rearrange it. So let's rearrange 2x minus 2x, okay, minus 8 equals 0. This is now what? The quadratic equation. Now, for us to solve this quadratic equation, you know, you see what? We have a coefficient of a here, like this form. The quadratic equation take this what? Ax square minus bx plus c equals 0. So if you look at this, the coefficient of a here is 3, coefficient of b here is 2, right? And c here now is minus 8, okay? Now, for us to get this, then we multiply 3 by 8. We multiply 3 times 8. So that it will now, after that, then we now factorize the middle, which is the coefficient of b here. And c, two values that by the time you add together, will give us minus 2. And by the time you multiply it together, 3 times 8 is what? 24. By the time you multiply that two values together, will give us what? 24. So if you do that, I think the possible values that we thought of here is going to be what? Minus 6x plus 4x. Minus 6 times plus 4, that is minus 24. Now, minus 6 plus 4, that is what? That is minus 2. So we can replace minus 2x now with what? Minus 6x plus 4x. Then we can factorize. So we have 3x squared minus 6x, okay, plus 4x, okay, minus 8 equals 0. Let's put the pair in bracket. So we have this in bracket and the other one as well in bracket. What is common between these first term? 3x squared minus 6x. 3x is common. So we bring 3x out. What we have here is the x. What we have left here is what? 2. 2 times 3x will give us 6x. So we have 2 plus, look at this, what is common? 4 is common to both of them. So we bring 4 out here. What is common? What is left here is what? X. And 4 can multiply 2 to give what? To give 8. So we have 2 here, rather, equals 0. Now, having that, we can now bring out the common term, which is what? 3x, okay, plus 4. Because what we have inside the bracket is common. So we bring one of them, x minus 2 equals 0. So the first one here, let's equate this one to 0 and let's see what we have. 3x plus 4 equals 0. So by the time we are doing that, plus 4 comes to the other side. We have 3x equals minus 4, right? So we divide this by 3, we divide this by 3. X will now be what? X equals to what? Minus 4 over 3. The next one here, we have x minus 2 equals what? 0. So by the time we have that, okay, it's going to be what? X minus 2 comes to the other side and changes what? And changes to plus 2. So we have x equals to 2. Now, you see that we have gotten x values now. Then we need to know what our y value is so that we'll be able to get the what? The coordinate of point P. So for us to do that, what we just need to do is what? We substitute x minus 4 over 3 and x equals to 2 in the given function, which is f of x equals to what? 3x raised to power 3 minus x raised to power 2 minus 5. And that's what we are going to be doing what? In the next slide that we have here. So first and foremost, let's substitute x equals to 2. You know, that is very easy to do. It doesn't have a fraction. So let's substitute and let's see what we have. So remember that the function itself is x, f of x equals to what? X raised to power 3 minus x raised to power 2, right? Minus 5. Now, when x equals to 2, now what is this function of x? You know, this function now we can actually relate it to be the y. So y equals to what? 2 raised to power 3, right? Minus what? Minus 2 raised to power 2 minus 5, isn't it? So now 2 raised to power 3 is what? 8, right? Okay. 2 raised to power 2 is what? 4, right? Then we have minus 5. 8 minus 4 is what? That is 4. 4 minus 5 will give us what? Minus 1. So now let's look at this. So when x is 2, y is what? Y is minus 1. That is the first point. X is 2, okay, y is minus 1. So that's the first coordinate point, possible point for coordinate P. Okay, now let's look for the next one. When we have x to be what? Minus 4 over 3. Let's put it inside the function f of x equals to 3. X raised to power 3 minus x raised to power 2 minus 5. Now, after that, we have x into minus 4 Minus 4x raised to power divided by 3 equals to, so we have minus 4x over 3, everything raised to power 3 minus, okay, minus 4x divided by 3 all raised to power 2, okay, minus 5. So we need to do this, okay. Now the first one is, what is minus 4 raised to power 3? That is going to be minus 64, isn't it? 3 raised to power 3, that is 27. That is 3 times 3 times 3, okay. Now minus 4 raised to power 2, that's 16. Minus times minus is plus. 3 raised to power 3, that is what? That is 9, right? So we have 9, then we have minus 5. So the next thing we need to do here is what? We find the LCM. If you get the LCM, let's quickly draw that 27 and 9. That's the major thing. Let's look at it. First and foremost, 9 can go. So 9 can go in 27 how many times? That is 3 times. 9 in 9 we have 1. Remember we have 3 left here. So we have 3, 3. 9 times 3 is what? 27. So the LCM is 27. Now having that, then we draw our LCM line. 27 can go in 27 1. 1 multiplied by 64, that is minus 64. Okay. 9 can go in 27, right? That is 3, right? Isn't it? We have 3. Isn't it? 2. Isn't it? So having that, what is going to be our answer? 9 can go in 20. So since 9 goes in 27 3 times, now 3 times 16 will give us what? 3 times 16 will give what? That is 48. So we have 48 here. Okay. Now, you know, this one is just like we have overall. 27 times 1, that is what? That is 27. 27 times 5 is what? That is 135. Remember, we have a negative sign here. So we have minus 64, minus 48, minus 35. That's going to give us minus 247 divided by what? 27. Now, if you look at that using our calculator, how many times can 27 goes in minus 27? We are going to be having minus 9.15 because of the approximation. We approximate the other value after 4, then you have 5. Okay, now, so this one is telling us that when our x is minus 4 over 3. What is minus 4 over 3? X is minus 4 over 3. Okay. Y is what? Minus 247 over 27. Let's convert this to decimal. We can have it to be what? This is going to be 4 over 3 is 1.33, right? The occurring decimal. Then minus 247 divided by 27 will give us minus 9.15. Now let's look at the tangent of the curve. How do we go about the gradient? Okay. Now equations of the tangent at a given point. Equations of the tangent of a straight line can be calculated using what? We have y equals to mx plus c, where m is the gradient and c is what? Is constant. Okay. Now we have this question here. It says find the equation of this tangent of f of x equals to 1 over 2 x raised to power 2 plus 3x plus 1 at point when x is 1 over 4. Okay, when x is 1, y is 4 number 1 over 2, and where we have point where s equals 1. So what this one is telling us that we differentiate the first principle. After we are done differentiating, we are told that the gradient is when s equals to 1, then we are going to be inputting the value of x equals to 1 in the solution of our first principle. Then after that, we are going to be using this formula for gradient y equals to mx plus c to calculate the gradient of that curve. Okay, so first and foremost, let's differentiate f of x equals to 1 over 2x, okay, 1 over 2x raised to power 2, right, plus 3x, okay, plus 1. By the time you differentiate it, it's going to be what? 1 over 2 multiplied by 2, x 2 minus 1, okay, plus 3, the power of x here is 1 multiplied by 1, x 1 minus 1. Differentiation of the constant will give us 0, okay, so we have 2, we cancel 2 here, 2 minus 1 is 2, so we have s left here. X raised to power 1 minus 1, that is x raised to power 0. Under indices, x raised to power 0 is 1. 3 times 1 will give us 3. So this is the function after we are done differentiating very first time. Now they are telling us that when our x equals 1, so we are placing that in. Wherever we see x now, we replace it with what? With 1. So 1 plus 3 will give 4. Now they gave us this point when we have point when x is 1 and y is 4 whole number 1 over 2. We should use the formula equals to mx plus c, y equals to mx plus c to get our gradient 4. So from here now, if you look at it, the gradient has been derived to be what? The gradient here is what? Is 4, right? Now, x is what? Under this point, x is 1, and y is what? Y is 4 over 1 over 2. We want to get the constant so that we can form this equation. So, okay, so we have 4 over 1 over 2 equals 4, which is the gradient, multiplied by 1 plus c. That is 4 over 1 over 2 equals 4 plus c. Now, take 4 to the other side. It changes to what? Minus. So we have 4 over 1 over 2, okay, minus 4 equals 2. Now, having that, let's change 4 over 1 over 2 to what? To an improper fraction. 2 times 4 is what? 2 times 4 is 8. 8 plus 1 will give 9. So you can add that to be 9 over 2 minus 4 equals c. You find the LCM. The LCM here is what? 2. 2 and 1. The LCM is 2. So 2 can go into how many times? 1 time. So we have 9. Okay. 1 times that will give 9. Now, 2 can go in 1 how many times? 2 can go in 1 2 times. So 2 times 4, that is what? That is 8 equals c. 9 minus 8 is what? 1 divided by 2 equals c. So c here, which is the constant, is half. Now we come back to this formula. Y equals to mx plus c. Now from here we have gotten that c is what? 1 over 2. So m is what? M is 4, which is the gradient. So we can now form the equation of the tangent of a straight line, which is y equals to mx plus c, where our m here is gradient, which is 4, and our c is constant, which is 1 over 2. So we have y equals to 4x plus and that is the equation of that tangent at a given point on this equation. This takes us to the end of our class. We want you to subscribe to our channel www.edubbey.com for the full interactive content of this class.